So in the last video, we talked about how important it was to determine the sequence or the identity and arrangement of building blocks within the genetic material of a virus. But the other part that's super important about targeting a virus for vaccine development is knowing the shape or the structure of the spike proteins on the surface of the virus. And so there have also been major advances that have been made in the technology that allows us to determine the structure of those spike proteins. So previously, 20, 30, 40 years ago, the big way that we determined the structure of a protein was a technique called X-ray crystallography. And so with X-ray crystallography, the way it works is you take your protein, you turn it into a crystal, and then you bombard it with X-rays. You take it to the synchrotron, you hit it with X-rays, and then the way that the X-rays interact with the matter and diffract allows you to map the electron density and therefore the identity and location of atoms, and then you can back out what the whole structure of the protein is. Now, this was a favorite technique for a long time because it allowed you to find individual atoms if you did a good job. Problem is that proteins don't necessarily like to make crystals. So it could take months, years, and some proteins won't even form a crystal and you just don't know what's going on. So about 10 years ago, I think it was around 2012, 2013, there was another technique that was developed to give you the same resolution so you could still see individual atoms, but you didn't have to go through the time-consuming process of turning your protein into a crystal. And so this is cryo-electron microscopy, or cryo-EM. And so it actually allows you to take a frozen snapshot of your molecule and find the individual atoms, but without turning it into a crystal. And this is such a huge advancement that it actually won the Nobel Prize in 2017. So with these increases in technology advances, so being able to quickly determine the sequence of the genetic material within a virus, and then being able to determine the structure of the proteins on the surface of a virus, allow us to better target the virus with therapeutics. Not enough? Want to know more? Tune into my next videos for reasons 2 and 3.